So this talk is a tribute to Raymond Smullyan, and I can think of no better way of honoring Mr. Smullyan than to begin my remarks for you this morning by talking about myself. So I have to begin with a little bit of a confession. Unlike many people here, I have to say Martin Gardner really had nothing to do with me becoming interested in mathematics. I didn't discover Martin Gardner until after I was already interested in mathematics, and then I was very happy that I did. But he was not the one who really inspired me as a kid. That was really Raymond Smullyan. And let me tell you how that happened. I was about 9 years old, and my parents took me to a local bookstore. And I was into books at that point. I should mention this is in the time before the internet, right? So at that time, the only way to learn what new books were available was to go to an actual bricks and mortar bookstore and go look. And this might seem a little antiquated, but it was great fun. And I would go browsing through the store. And I was about 9 years old, and I was already interested in chess. So I would go to the puzzles and games section of the bookstore and look at the chess books. And then one day, I sort of struck out with the chess books. But I did notice in the puzzle section this sort of striking yellow cover with a very intriguing title, "What is the name of this book?" So I pulled it off the shelf, and I sat cross-legged on the ground, and I started reading it. And I was immediately hooked on it. Smullyan started with some simple brain teasers, what he called monkey tricks. And I had great fun. Even at 9, I was able to understand a lot of those. So I kind of prevailed upon my parents to buy me the book. And I think they figured I could be, there were worse things I could be hooked on. So they bought me the book. And I went home and started reading it. Now, after the monkey tricks, that's when he launched into his puzzles about knights and knaves. And I think most of you are probably familiar with the genre. The idea being that knights only make true statements and knaves only make false statements. And you're supposed to imagine that you've traveled to an island with these people, and you're trying to discern some information, whether you should go left or right or something like that. And the natives make horribly confusing statements from which you're supposed to deduce whatever logical consequences you can deduce. And I had no idea what to do with this. So I brought it to my father. And my father was a chemical engineer and sort of liked brain teasers and puzzles. And the way I remember it, he was in the kitchen cleaning up after dinner, and I sort of thrust the book at him. And I said, "How do you do this?" And he kind of picked out the book, and he looked at it for about 2 seconds and said, "Oh, well," and he very immediately just tossed off a very simple solution. And I was really impressed. And I decided, gee, I wanted to be able to do that. I wanted to know how this worked. And that's when I got started. And then, so that was how it all began. But it might have ended right there, if not for a second experience that happened shortly after. I was at the local public library, and of course I scampered off to the chess section, and I saw this very strange book with the title "The Chess Mysteries of Sherlock Holmes." And I knew who Sherlock Holmes was, and I knew what chess was, but I had no idea what this could possibly refer to, but I recognized the name, Raymond Smullyan. And this book added kind of a new twist, which is that it had an author photo. And that's a serious photo. That is, you don't mess with that. It kind of looks the same upside down as right side up. But yeah. But I mean, try. His puzzles are hard enough on their own, but with him actually staring at you, it's quite formidable. And suffice it to say, these were this was a book of what involved of something called retrograde analysis chess problems, which takes a little getting used to. If you're familiar with chess, you probably know problems of the sort white to play and mate in 3 or something like that. But these were actually logic puzzles that used chess pieces. So the idea was, given the position on the board and given that it arose in a game of chess that was played legally, your task was to recreate some aspect of the history of the game. And I had exactly the same experience I had had before with what is the name of this book, that I went from just not being able to do anything with this to eventually being able to solve some of the simpler problems. And then pretty soon I was able to at least follow the solutions of the harder ones, even if I couldn't work it out myself. And after that, I was simply hooked on Raymond Smullyan. And every time a new Raymond Smullyan book came out, I very quickly devoured it. And it turns out Raymond has quite an impressive output. He's probably best known for his puzzles about knights and knaves, but he's written in a great many other areas. In this book, The Lady or the Tiger, he has a very long section on what's known as combinatory logic, and this led to his great puzzle novella, The Mystery of the Monte Carlo Lock, which is another classic of his that maybe has been overlooked because of his knight and knave puzzles. In this one, Forever Undecided, he talks not just about Gödel's incompleteness theorem, but Gödel's second theorem as well. Once again, it's sort of a hallmark of Smulyan's technique that he would use puzzles and games and recreations to introduce very sophisticated, very complicated ideas in modern logic. And I have to say, having since gone on to graduate school and have become a professional mathematician, I must say I still find this one kind of tough going, but no less fascinating for that. Another one, a little fun with PowerPoint there. This one, The Magic Garden of George B., has to do with a Boolean logic, and he has another wonderful set of puzzles building up to ideas there. But of course, he doesn't just write about puzzles and games. He's also written quite a bit about philosophy, and especially the philosophy of religion. These are 3 of his books. The Tao is Silent. That's an especially noteworthy one. Nowadays, I mean, there are lots of books on Taoism and Buddhism. That's a very common thing now. In fact, usually if you go to most bookstores, you'll see a whole section for books of that sort. This was published in the late 70s, though, when this was, before it was cool, if you will. And it was quite a fascinating book. And these are 2 more recent ones, Who Knows and A Spiritual Journey. And and he writes with his characteristic lucidity and, joie de vivre. And if you're more interested in the really riveting reading, you can try some of his monographs on logic and mathematics. These are 3 of them here, Diagonalization and Self-Reference and First Order Logic, actually his very first book. And then this one on the end here, co-authored with his PhD student, Mel Fitting. And this is nowhere close, by the way, to a complete bibliography. I mean, I'm not just going to go through all of his books. I do, however, want to call your attention to just 2 others that I think are worth specifically mentioning. The one on the left there is the Gödelian Puzzle Book, and the one on the right is the Beginner's Guide to Mathematical Logic. And the reason I point to these 2 is that both of them are published in the last year, which is pretty impressive considering that Raymond is 95. And so I think it's pretty good. He keeps churning these out. In fact, the Beginner's Guide there, I think, has not actually been released yet. But yeah, so he's still going strong and still coming up with new ideas and just churning them out. Now, of course, Raymond has long been a fixture of the Gathering for Gardner conferences. In fact, he had planned on being here. Unfortunately, it was just not possible for health reasons. But these are a few photos that have been taken over the years. The one on the top there with our own Kate Jones. I don't know if she's still here. And Raymond, of course, is a very talented pianist, and that's him entertaining there. This is him down at the bottom watching a very good sleight of hand artist from G4G10. And there's actually a YouTube video of that. I'm especially fond of that one because if the photo extended just a little farther to the left, that's where I'm standing. There you go. This is a picture of him in his home, near his home in upstate New York, entertaining some locals. If you've ever had the chance to talk to Raymond, you know he is quite the raconteur and has just sort of an endless supply of corny jokes and constantly happy to throw logic puzzles at you. And actually, at G4G10, that's when I met Raymond for the first time. But I also met an editor from Dover Publications, and she came up to me after my talk that year and said, Jason, do you like Raymond Smullyan? And I kind of stared. I said, did you seriously just ask me if I like Raymond Smullyan? And she said, yeah. And I said, I replied with epic poetry. I mean, it was, and I said, why do you ask? And she said, well, they were interested in putting a tribute volume together for him. They needed someone to edit it. And they said, would you be interested? And I kind of stared, and I said, did you really just ask me if I'd be interested in doing that? And I said, of course I was. And actually, that book has now been published, literally just in the past week. There was a display copy out there. And it was a real thrill for me to put this book together. We called it 4 Lives, and that's after Raymond's 4 incarnations as a professional magician, as a very young man, and as a concert-level pianist, and then as a mathematician and also an author. And that's where the 4 Lives come from. And it was a real thrill, because when we decided to do the book, I actually spent a weekend with him at his home in upstate New York. And it was really, it was quite a treat. I mean, we would go out to a local sandwich shop, say, and he'd always have a deck of cards with him, and he'd go running off to different tables and do sleight of hand and some very impressive tricks. And he seemed to just know everyone in town. Maybe we'd be standing in line, then all of a sudden he's walking off to one table and shaking hands with people at a second table and winking to whoever just walked in the door. And it was great fun. And it was really a thrill. It was really a thrill for me, just because you very rarely get to meet your idols in life, and when you do, they rarely live up to your expectations. But I not only got to meet Smullyan, I can say he more than fulfilled everything I could have hoped for. Now, that ends the first part of my talk. Okay, so we now come to a brief intermission. Let's see, I got about 5.5 minutes, perfect way I planned it. And for the second half of my talk, I got to thinking, in the course of doing this book, I completely immersed myself in Smulyanana, or whatever the word is, and reread all of his books, and I started overdosing a little bit on Knight Knave puzzles. And you see some elaborate dialogue, and you say, oh, okay, suppose the first guy's a knight. Okay, then his statement is true. And you go from there. And I got to wondering, though, if this could be pushed in another direction. What's sort of the future of knight-knave puzzles? And I came up with this idea of trying to extend knight-knave puzzles to non-classical logics. Okay, now I think if you're not familiar with this, the word logics, plural, probably has a strange sound to it. Logics? That's ridiculous. There's only one logic. Okay, there's correct logic and incorrect logic, but that's it. Well, that's not really true. And actually, if you follow the course of modern logic, it's very similar to the way geometry developed, in that it used to be that Euclidean geometry was just the word. I mean, it was just, that was it. Euclidean geometry was the truth. And non-Euclidean geometry, to the extent that it was even consistent to talk about such a thing, couldn't possibly be anything more than just a silly pastime. But of course, that's not the view today. Nowadays, the way mathematicians view this is that there are different systems of geometry, and Euclidean geometry is one, and various systems of non-Euclidean geometry are others. And it's not that any one system is more correct than any of the others. It's just that the question you should be asking is, is this system useful or not useful? It's not correct or incorrect. It's useful or not useful. And logic is much the same way. What you think of as logic, what we refer to as classical logic, is just one system among many of logic. And other kinds of logic could have some value. So I just, in the last few minutes here, I just want to give you a little taste of what I have in mind. So let's imagine that you go to this island, and some of the islanders are knights and some are knaves, and knights only make true statements and knaves only make false statements. Well, it turns out that the island's biologists made an interesting discovery. It turns out that knighthood and knavehood are not permanent conditions. Okay, it turns out that knights and knaves cycle between the two states and throughout their lives. So you're a knight for a while, and then you enter this transitional phase where you're partly knight and partly knave, and then you emerge at the other end where you're fully knave. And this presents a little bit of a problem, okay? Because suppose you meet some guy, Joe, and Joe is in the transitional phase, and you say of that person, Joe is a knight, or Joe is a knave. Is that statement true or is it false? Because classical logic says it has to be one or the other. Those are the only options in classical logic. It's true or false, and that's it. Okay? And every proposition has to be one of those, exactly one of those two values. But here, there's a bit of a problem. It doesn't seem right. Joe's a knight? Well, no, not really. Joe's a knave? Also, not really. So it's a little too confining. Okay? So the island's philosophers got into this game, and you know how philosophers are, right? And they decided, we need a third truth value. Okay? And we'll call this truth value n. So you have true, false, and neutral. And this neutral truth value applies to statements that are neither true nor false, or that are vague in some way. So we say that if you meet someone in the transitional phase and you say of that person, Joe is a knight, then we assign that statement the truth value n, neither true nor false or neutral, however you want to think of it. Okay? And that's how logic worked here. Okay? You have three truth values, true, false, and neutral. I should also mention, so we now also have three kinds of people, right? Knights who only make true statements, knaves who only make false statements, and then you have these people in the transitional phase, and the sudden loss of identity that they suffer from this, very disconcerting, and so they just hedge their bets and only make statements with truth value n, okay? And we call those people neutrals. So here's a little puzzle you can think about. Here we go. So suppose you meet Alex, Beth, and Carl, and they make these statements. Sort of a cyclic attribution of types here. So Alex says Beth is a knight, Beth says Carl is a knave, and Carl says Alex is a neutral. So what can we conclude from this dialogue? Okay, well, I think we can reason like this. We say, first of all, Carl is not a neutral. Okay, because the statement he made is simply not the kind of statement that can have the truth value n. There is no ambiguity about being a neutral. You either are one or you are not one. Okay, so Carl did not make a statement with truth value n, so he is clearly not a neutral. Okay, so then the next question is, well, could he be a knight? Well, if he's a knight, then his statement is true, and that means that Alex really is a neutral. Okay, but that's only possible if Alex's statement has truth value n. But if the statement Beth is a knight has truth value n, that's only possible if Beth is actually in the transitional phase and is actually a neutral. That would require her statement to also have the truth value n. Okay. But that's a contradiction, because in this scenario, the statement Carl is a knave is simply false. Okay? It does not have truth value n, it has truth value f. Okay, so that's out. So the only way out of this is to assume that Carl is a knave, and now everything unravels. That makes Beth's statement true, so she is a knight, and that makes Alex's statement true as well, so he is also a knight. And I see I'm getting low on time, so I think I'll just skip over the next one. Obviously, the next place to go for this is, in standard propositional logic, you then look at and statements and or statements and if-thens and biconditionals, and you develop rules for how to manipulate the truth values of those statements with respect to their simpler parts. And of course, you can do that for this three-valued logic as well, but I'll just skip over that part. and step over this exceptionally brilliant puzzle that you're missing. But anyway, and we'll just cut straight to the end. Yeah, so anyway, that's just a little taste of what I had in mind, of extending these knight-knave puzzles to non-classical logic, and there's a lot more places you can go. I have a lot more puzzles on three-value logic, and I have a preprint of a paper that I wrote. So if you are interested in this, I'd be happy to email that to you. But of course, there are many other systems of non-classical logic. First of all, there are other systems of three-valued logic. Okay? There are lots of ways to define your operators there. There's also something called fuzzy logic, which we have a large computer science contingent here, so I'm sure you're familiar with that. There are also things like modal logic, I think that's all really unexplored territory and would be really interesting. So to be continued, and thank you very much.